Now that we've gone through the different lymphoid organs, we need to kind of shift gears and look more into how the actual immunity works, how your defenses function. So to start with, kind of refreshing and going back again, make sure you're remembering the idea of innate immunity. Again, innate immunity is not specific. So it simply attacks anything and everything that's foreign. It's a way of trying to prevent infection into the body. Now, in this case, there's different types of innate affections, or innate immunity, I should say. You have these surface defenses. Things like your skin prevents things from entering. You're going to have the hair and mucus in the nose. So as you're inhaling, the air you bring in can have pathogens. It's not sterile. Then other things over here, internal defenses, still innate. That means not specific. Doesn't matter what you inhale in. If there's something that's foreign, this can respond. From phagocytosis to inflammation to the natural killer cells, they're all working to simply destroy. They don't care what it is, as long as it shouldn't be there, it's gone. And then you have adaptive immunity. Adaptive immunity is more like a third line defense, let's call it. This is going to be specific to the antigen, which means it's specific to what the pathogen is. Because each pathogen is going to have a specific antigen that identifies it as this or that. So your body is going to have T cells and B cells and antigen-presenting cells. They're all specific to the particular antigen they're trying to get rid of. So they're a little bit slower, but they're very precise. They're very accurate. So both the innate and adaptive actual portions of immunity. So again, those innate surface membranes, they're all meant to stop, all meant to prevent anything coming in. Innate is simply a physical barrier. It's not going to try to stop that pathogen or that particular one. Just stop everything. So again, that's the innate. Keratin, think back to AP1. Keratin is in the keratinocytes, the skin cells. Keratin itself, which makes up a large amount of those keratinocytes, is resistant to weaker acids and weaker bases. It's also resistant to a lot of bacterial enzymes and toxins, which means that these bacteria and different components are trying to get through. A lot of them aren't functional on the skin because keratin helps prevent their functionality. Mucosa. So, mucosa, there's no mucosa in the skin. Mucosa is in your mouth, mucosa is in your nose. So mucosa has similar aspects. So as things enter your mouth or nose, there's similar defenses built into the mucosa membrane of those systems. But there's also other components here, other things that are found on these surface barriers. There's different chemicals that are secreted, different molecules, different enzymes, different things that really help out to keep foreign pathogens away. First off is skin acidity. Your skin, well, I might think of it as more dry because it's drier than your mucous membranes. Your skin still has a coating on it. And that coating contains a little bit of an acidity to it. So therefore, it kind of changes the environment from being a neutral, which is easier for most bacteria, to slightly acidic, which isn't as hospitable for a lot of different bacterial strains. You have lipids in the sebum, dermacidin in your sweat. Well, you're saying lipids in my sebum. Yeah, your skin is covered in oil. That's the sebum. Helps keep the skin pliable and prevent from tearing. Sweat, dermacidin. That chemical is going to help try to destroy bacteria. You say, well, I don't always sweat. True, you don't sweat heavily all the time, but your skin is always producing a little bit of sweat here and there because it helps the skin's productivity. Hydrochloric acid, protein digesting enzymes. Now, obviously, these aren't on the external surface. Now we're looking internally. We're in the GI tract. So this is now hydrochloric acid. It makes your stomach pH down to a 3 or pH of 2. A very acidic and inhospitable environment for most bacteria. Protein digesting enzymes. Well, proteins are what make up most things. So if you're digesting the proteins, That means you're breaking down the proteins that these bacteria have. Lysosomes. Lysosomes are meant to destroy. They encapsulate and then break down what they encapsulate. Your saliva is full of them. So it's another good reason to chew your food thoroughly. Not just to help you swallow, but make sure the saliva really mixes in with everything. So if there is foreign pathogens, the lysosomes can start doing their work. Lacrimal fluid. Well, lacrimal fluid is not in your mouth. Lacrimal, we're thinking more in the actual tears. So the lacrimal fluid from the lacrimal glands is helping every time you blink. That fluid not only moisturizes your eye, but it has bacteria-fighting components, making sure that the air that touches your eye and the potential bacteria that touch your eye aren't able to get around and inside your body. And then mucus in general, whether it's from the oral cavity to the nasal cavity to the GI tract all the way down, mucus itself has plenty of these features not only to help with the chemicals, but simply to trap. Mucus is sticky. So it gets these bacteria, these pathogens stuck in the mucus, and then you can get rid of the mucus out of your system or prevents it from entering into your system. But your respiratory system has a few extra modifications to help out with this mucus. So the respiratory system has hairs in there. Think about the nose, there's hairs. Going down the actual windpipe or the trachea, there's little tiny cilia sticking out. Little tiny hairs, we'll call them. Those all are meant to help with moving the mucus and trapping the bacteria. The cilia that are found throughout the intestine, throughout the actual windpipe here, the trachea. Those are meant to pull that mucus up. They're found also in the very main bronchi branching off. So the mucus that's in that area, the upper portion of your respiratory tract, is being pulled up, pulled up, pulled up. All those pathogens that were stuck, all that debris that was stuck in the mucus is pulled up into your throat. It's then dumped down into your GI tract where it's destroyed and you don't even realize it. Only time you might realize that is if you have allergies and you have a whole lot of mucus coming out. You have an increased production. But normally it just comes on up, dumps down to the GI tract, and your stomach just destroys it. So looking at some of the functionality of how your body's trying to protect itself. From the mucous membranes to the cilia to the specialized chemicals, both innate and adaptive.